Welcome to this data engineering class. I will just do a quick overview, quick review of what we covered last week. We started with, accessing the module, that's Spark section from PySpark.sql import Spark section. I showed you how to do that, and I explained to you that for you to access this Spark, the app name, and to run Spark, you do Spark section that you have here .builder.app name. Then you can use any name. I use som class 18.get or create. And this aspect of Spark section is Spark data frame that we're going to focus on. But along the way, you will see a bit of RDD, and I showed you an example. I gave an example of columns. L_code as a column. We want to add a column to a particular to figures, values that we have. So we call the value as this. I said this is tuple in a list, right? Tuple in a list. You pass in the tuple, which are the rows, the columns. The rows, the first row, second row, and third row. And I showed you an example. And from there, I said, let me take this Spark Lazarus just to make things more clear. So we'll be using Spark. And I said, you can access this Spark here. You can access this Spark. 1 second. Let me run this again. While we're doing that, so then from PySpark.sql import Spark section. So it's there now, and I said you run Spark section, Spark equals to Spark section .builder.app name. Then we created header, which is the column. It's still loading. Let's see if we have any issues somewhere. So it's loading. Everything is going fine as expected. And I mentioned that we're creating a column. We have rows, row 1, row 2, row 3. I showed you an example of the data. And I said to create RDD, you can have access to RDD module here, spark.sparkcontext.parallelize. And I told you about RDD is row base. So most of the time, RDD is very good when it comes to accessing data in rows, not in columns, in rows. I will give an example here. Can you see in rows? There is no column there, no column header. So in rows, you'll be able to read this RDD, you pass in the value. So in some cases, you have situation where you have a CSV file with no header, you can pass it to RDD and do your transformation. So RDD is very good in handling data that way, not in column based, but in row based. And I said to access RDD, you see, I use collect, RDD.collect. Collect helps you to access data that we have here. RDD collects, just like you're using show in data frame. So in this case, I've shown you an example of RDD, how to read data in RDD, and how to show data show in RDD. And I went further last week to show RDD, you are converting your RDD to data frame. I said you can read data frame you can create data frame using 2DF and also create data frame. 2 ways of creating data frame, 2DF and create data frame. So in this case, I'm creating data frame from RDD using 2DF, and I pass in the columns there. I told you RDD is row based, no columns. So in this case, we are passing it to data frame, which is column based, and we are passing the column names there. And as we pass it, we are able to run show, and we are able to read our data, if that makes sense. Now, I went further to print schema. I said, here you'll be able to access your data type, the format of your data, and here we can see string as the data type, double as the middle name. Then we went further I said we can create RDD using create data frame. Spark that we have there, then pass create data frame, pass in your RDD and add your column. Pass into df. In this case, I pass into df here. So I combine create data frame and to df together here. And after running it, we still get the same results. And again, I went further and I showed, remember we changed this one to Spark now. And I said we can pass in create data frame directly without RDD because we are saying that this data is still row based. We can capture it as a file itself without using RDD. Then I said we can pass into df, which helps us to capture the volume and add the schema to that data so that we can see this column added as LA code and middle age. And when we run it, we generate the same results. Any question? Any question at all? Okay, let's continue. Now, and I said we can also add a schema to the data directly by importing the following modules, which are struct type, struct field, string type, integer type, and float type. So depending on what you need, the best practices is for you to import the module or the library that you are interested in. It's not compulsory you import all modules. Let's say, for example, I don't need integer type. I will take it off from here. The reason is that when you are developing your application, you don't want it to be heavy. You want it to be very simple and light. Because don't forget, when you are loading all this stuff, the application is going to go through wherever you are importing here. So if you are not using it, it's not necessary. It's not necessary you import it. Does that make sense? Okay. Nobody's responding.
No, we are following.
Okay. Yeah,
Yes.
thank you. So when I'm importing all the modules there, it's not necessary that I import all the modules like float type, string type. If I'm not going to use float type, it's not necessary I use float type. If I'm going to use integer type, if I'm not going to use integer type, it's not necessary I import integer type. But in this case, we need struct field. We have struct field imported here. We need integer type. So in this case, let me put integer type and I will delete float type if we don't need it. Then if I run this, and this is the these are the rows, first row, second row, third row, the value. Then we want to add schema. Schema is like you are adding a column, just like we did here. We are adding column. We call it column here, columns here, which is this. We are doing similar thing there. But what makes it different a bit is that in this case, we are specifying the exact data type that we are interested in. Because in that case, you just add a column. It might not pick it correctly. It might be, maybe it should be data type, so it might be float type. It might be picked as, it could be picked as string type. But here we are specific about what we want our column data type to be. We are specific. We say struct feed, LA underscore code. It should be string type. And we said it should be true. True means we're assigning string type to that particular column. Struct feed, middle age. It should be integer type and it must be true. If you say false, it will just assign like a string to it or just generate a default data type. And we said level, it should be true, assign it as string type, because the reason why we did that intentionally is that we already know that if you see middle is alphabets, is a character. So we can capture it as a string. If you see this one, it looks like an integer, that it doesn't look like floats. But what if in the future, let's say in this case, we now have data in floats? Should we have to stick to integer? We might decide to change our format. Maybe we include double type here. Why double type? Because we know our data is in double. 1622 is double. So we can decide to use double type instead of integer type. Can you see? So you have to like think logically from the beginning that why do you want to do this transformation? You have to understand the logic behind the transformation. What do you have to do? What do you want to capture from beginning? Or should I use float type? Let's see. Maybe float is good. The reason why I say float is good, what if in the future our data comes they come as figures come as decimal points? Maybe float is going to be good. Then we can decide to change this one to float type. Then when we run this, so it's saying float type is not what? Defined. So let's run it here because I didn't run it. Let's see if it's going to capture it. Can you see? Because I ran that part line because I added it without running this. Then after doing that, I'm able to do the transformation. So let's do Spark. Then we're passing in the value now, schema value that we have created, which is the schema. We can call it schema. Let me call it schema. Schema is the column. We've created a column. Let me see if we... Can you see? Can you see the column? So this is the schema. So we're printing it out. But it's similar to what we've created there. So to me, it's not necessary we do that. So I'm going to pass in that schema here, which is the column, to the schema. Schema equals to schema. I can decide to call it schema here. Let me say schema value. Then I'll pass in to that schema here. Schema value. Spark.create data frame. What's the data? Data we have created here without column, without header. I'll call it header. Or without schema. Don't forget, they are all the same. Header, schema, columns. So when you hear header, schema, column, they are all the same. So schema, pass in the schema, and you add the schema to this. So schema value, so it's saying something there. Let's see where we are having error. Cannot accept object 210 in the type ints. 210 in the type ints. Okay, that makes sense. Maybe we have to change. Can you see it say float, right? So it's not accepting that. So let's see if we use double type. Let me see if I can use double type, and I'll pass in double type here. And do we need float type anymore? You take it off. Run this line of code again. Let's see what we have. If we are going to get it fully. Okay. So this one is saying cannot accept double type. So maybe it's asking us to use it as integer because it looks like integer, right? So let's run it again. Let's do this. Take this off, integer type. Run it. There you go. That means we are good. So it's accepting this as integer because there is no decimal point. Okay. Sometimes we have another module called long type. Long. Can you see long type? So sometimes you can use long type to replace integer type. Yeah, Koblo.
Okay, so I just feel like why that code did not run was because the values you've added were all integers actually. So there was no float there. So I think that's where we got the error. So now that you've only specified integer types to be true, and
Yes.
then the values you've added are true values of as integers, that's when it's gonna run.
Okay, that's fine. But
All right.
in some situation, let's say, let's say for example, you have integer all true, and suddenly you now see a float, maybe one float out of it.
So I think what will work better is when we have the integer type there as an option, as well as a float type as an option there. Not
N-
like taking it all out.
No. Yeah, that's a good idea, but in this case, because they are all integer, in some cases, you might not need to use this integer. It might be that you need to use long type or double.
All right, so that's fine, sir. Thank you, sir.
You're welcome. You are correct. So sometimes it depends. Like in this case, we know it's typically integer, but I've seen a situation where maybe the Google Colab that we're using is only accepting this as integer. If that it makes sense. But in some situation, I've seen situation where within AWS environment, it doesn't matter what you have there. It will, if you use float type, it will capture it as float and it will convert that 210 to 210.0. Does that make
Yeah,
sense?
yeah,
So,
exactly.
so, so,
Yeah,
so
exactly.
what if your data come in the future as floats? Because you have to think ahead of some changes to, to your data. Because there might be a situation where data will come as integer and suddenly it will change to decimals in decimal points. How do you want to quickly um, capture that? It has not happened, but you're trying to think in the future that it's going to happen. So that's the essence of using that float type, or sometimes you go for maybe long type, you understand? But Spark allows long type, double type, float type, and integer type. So that's one good thing about Spark. So it's a bit dynamic, but you have to think ahead what is going to happen to your data. So in order to know, should I add float type? Should I add this? But in this situation, we can go for integer type because there is no decimal point at all. And that's why, like Koblo said, because we don't have any decimal points. In this case, that's why it's forcing us to use integer type. So now let's continue.
Please, can you talk more on the long time? You
Long
wanted
type.
to tell us about the long time.
Yeah, long type is similar to integer type because it it can capture, maybe you have billions of record. You understand? Like this, can you see it's long? You know the meaning of long. So double could be from 1.6 to 2, you understand? Long could be, so sometimes you interchange between long and double, and sometimes with integer and floats. Does that make sense? But
Okay.
most of the time, when you see data, long data like this in Spark data frame, you go for like sometimes double. You go for, if it doesn't have decimal point, go for double and long. Does that make sense? So,
Yes.
but I can actually conclude for you now. You might find yourself in situation why the code, the line of code might force you to use data type, different data types. So you have to, in this case now, we try to use double. What happened? We were forced to go back to what? Integer type. So you have to take note of all those stuff. It depends on the system, the application itself. So in this case, we are using integer because we are forced to use integer. So now let's continue. When we run it, then we have our results. And when we print the schema, it will generate as integer type, string as we have specified here, string, integer, and level string. Let me see, let me see if I try, okay. I want to see what will happen if I try long type. So let's do integer also. Let's see. put integer there. So let's do, just want to see what is going to happen. Let's see. Can you see it's gone through? Can you see? You see it worked. I don't know if I'm making
Yes, it
can you
does.
see now? So sometimes it depends on what you want to do, but most of the time it varies between long type, integer type, double type, float type. So long type looks similar to like integer type in this case now because we tried double and it didn't work. I think you saw it. So long type and integer type are both applicable to as schema, as struct feed, a schema. I'm sorry, struct feed in this case, the data type. So we are able to do it as long. So depending on what you add there, we determine what result you are going to, the result you are going to get. So in some environments, especially in the cloud environment, sometimes when you are loading data, it will automatically capture the data type. Especially when you are dealing with AWS Glue and you are loading data, sometimes it will tell you this data is a long type. Sometimes it will tell you this data is a double type. This data is this. Even if it has decimal point, might be able to capture it as a long or as a double. It will automatically generate the schema and assign a data type to it. But not in every situation. In some situation, you have to do it. And let me tell you something. When it comes to assigning data type to data, sometimes when you are working in a commercial environment, it's more advisable you when you are dealing with production, don't let me make things complicated. Let's keep that. We'll be talking about that maybe if I have some time or maybe during any other discussion. So now we've seen long time, string, and we've seen string, long, and string. Now we've captured that. So remember, I've changed this one to Spark. So this is another one now. So now we are done with that. We've been able to assign our schema. In this situation, we are dealing with the real data now in CSV file. I forwarded the data, CSV file data to you. I think we worked on it recently. And if you see, in this case, we want to read our Spark, spark.read. You remember when we are creating data frame, we didn't use read. But here we want to read our data. How do we read our data? Directly, it's this CSV file. Let me see if I have the CSV file here. I'm going to stop sharing for a few minutes and I'm going to then I can load the data from my side. 1 second. Let me see if I have UK data new under my download. Okay. Yes, I think I have a copy here. So let me copy. So I'm going to upload it. I'm going to share my screen in a few minutes. Just let me. Okay. There you go. Brilliant. I'm going to share my screen back now. One second. I'm going to share. Okay. Now, this is the file now. This is our UK data new CSV. I've uploaded into this environment. So we're going to load it now. I've added it here, so it's more easier for us to load. So if I want to load it now, I can do here, copy path, here, copy the path, and add the path here. When you add the path here, let me do paste. Let me do paste. Can you see? So if I add this one, so to read your data, a CSV file or any other file, you have to consider the data type. Here is in CSV. Remember, .csv. So when you are doing Spark, you pass in the module read dot format. What's the format? CSV file dot option. You want to capture the header, which is the schema. You know, I told you about schema, header, and columns the other time. So header equals to true. Dot load the file. When I load the file, I can do count 323. Remember last time I showed you something. I said whenever you want to read a data, whenever you want to load a data, in some situations that you find yourself that after as a developer, you've developed the product and data is not made available. How do you want to know? I explained this. I think we've covered this already. We covered this last week. So I said if df is greater than 0, that means data is available, then you can read the file. I showed you this last week. I remember now. I will spend 1 hour. Can you see what I was trying to say, Jamie? Now, so now I've shown you an example that if df.count is greater than 0, that means 323 is greater than 0, that means data is available. But if it's 0, then file is empty. And I showed you an example. We deleted the file, we saved it, and we tried to load the file, and it showed us file is empty. So in this case, as a developer, after developing this product, you can capture this error and send it as a notification to other developers, maybe through emails or through maybe SNS notification via Slack or Microsoft Team, so that everybody will be aware that something has happened. Then they can chase up with maybe the person, the user, or the person in charge of that data. That, oh, data is not made available again. Imagine what it's going to cost if you don't know that data is not made available and users are expecting data to be available from their end, but it has not been uploaded. But as a developer, you've captured it from your code, within your code, and you've been able to get notification immediately, and you quickly get in touch with data providers, or maybe it's coming from a database, or if it's coming from data warehouse, maybe it's being sent via web app or any other application, then you'll be able to know and quickly chase that data up to prevent any unavailability of service. Does that make sense? So that's why in your code, you have to make sure you capture things as much as possible. Now, let's go on. Now, we created, okay, in this case, I have the column captured. Columns are being captured in this case, right? I think we make some, we tried to edit this file, and we edited this file and we got few things added at a point. So now,
Sorry, 1 second. This count 300 and something you got, is it all the rows and columns, or is it all the rows?
all the rows, no column, not including column. Row 1, row 2, up to 323.
Okay.
Yes. Now let's go to the next line. In this case, you see, I added the column, right? Let me now remove the header. I want to remove header from this data and then assign header to it. So now I'm coming 1 second. I'm going to open it from different windows so that I won't record the environment. Okay. Okay, 1 second. Yes, I'm gonna save this one as no header. I'm coming in a minute. So okay, let's see. Oops. I'm gonna take this header off. Delete. I'm coming. I'm almost done. Just want to prepare the data and then upload it. So I'm gonna delete the header. Delete. Let's see. We don't need the code there. Good. That's it. Fantastic. So now this is the file. Look at this file now. If you see this file clearly, there is no header there. We don't have columns. We don't have schema added. It starts from row 1 up to row 323. You see what you said now, what you asked. Jamie, this is the row. This is the last one, 323 that we did using cans. Now, I'll save that. Then if I save that, I can now upload this file. 1 second. Okay. So I'm going to upload this file. No header. No header file. Header. Now, I'm going to upload that. No header. So if we copy the path here, then we can start reading this data. So I'm going to do something new here. Here we said the header equals to true. Okay. So in the case that we have our data with no header, we want to create header and add it to that data. That's 1 second. So we have a column. This is the schema. So I'm going to change this because I did not 1 second. So let me do this now. In this case, we're going to replace this path as this. So I don't want to make things complicated for you. What we are going to do is that I won't cover this side because the more I cover this, the more it makes it a bit difficult. I won't cover this part. It's going to make things more difficult for you. But what I will do is that I will exclude that part. So I'm going to do Spark. In this case now, I'm going to do file path. Then I'm going to do data frame. Let's say no header df. I'll call it no header equals to Spark dot read dot format. And what's our format? CSV file. Then dot option. Header equals to what?
False.
False, right? Okay. So we're still going to do something there, but we do it gradually. Dot load. Then don't forget the file path, which is here. We can decide to do this, copy this here, pass it here, or
Use
just
PySpark.
file. Thank you. File. Just use the file path that we have there. And that's it. So if we read this data, let's run this. Let's see what we have. Then we can do df underscore no header dot show. Can you see? Can you see? There is no header there. So the header is just assigned by default this. If we say header equals to true, what do you think will happen in this case?
The others will be loaded.
It will be loaded from where?
From the UK data, the file.
No.
It will show null because there is no header.
Okay. Any other suggestion?
In fact, it will not run.
Any other suggestion? Okay. My own suggestion is that when you run this, it's going to automatically choose as the header. Let's see. That's it. Because you've already specified that header equals to true, it's going to capture the first line, the first row as the header of the data. Does that make sense? So if you say header equals to false here, then it's going to create the default header for that particular data. Let's see what we can do in this case. Let's see what we can do. Remember what we did what's it called with the schema type. If you remember the schema type, how we pass in the schema. So we're going to do the same thing here in this case. So let's go to this. Spark. Okay, we are here. Yes. Spark.read does this, and we have our schema for that no header. Let's say, where's the no header file? Oh, I've deleted it. Okay. So let's say, this is the data, right? We have this. So let's create our own header. Let's create our own header. Let's do new column header. Already we've seen the results. So let's name it. Let's say Kanti, right? What's the first one? Kanti. Then what's the next one? ID. Should we say Kanti ID, right? Kanti ID. Then what's the next one? Next one looks like a number. Let's say it's called middle age. Middle underscore age. And let's call the next one maybe adult. Yeah, it's adult. Let's say adult age. And let's call the next one. So we have middle age, adult age. Let's say teen age. Let's call it. Oh, sorry, mistake here. Let's say teen age. And let's call the last one, which is because we have 4 different columns for numbers. Middle age, adult age, teen age, and let's say young people. So we want to assign a column to that. I will call it, or new column, let me say new column schema. So in this case, what we're going to do is that when we run this now, and we have this, we have to pass in our schema here. There's something called dot schema. Then you pass in your new underscore column schema here.
Here is a quotation.
So oops. There's a mistake somewhere, right? Oh, sorry. So because I said this one is false, so let me just do true here. Oops. True, and let's pass in this. Okay. It's saying there is a problem somewhere. Let's have a look. Schema should be string or struct type. Okay. Brilliant. So it's giving us a clue there that it should have been a struct type. Brilliant. And I'm so happy that it's very glaring that we have to apply strong type. Remember the strong type we did here? Assigning the data type, we need it. We now need this now. So I'm going to edit this just to save us time. I will go back here. Then I will need to assign the correct data type. So I'll copy this. Our county is what? County. Passing. And what does it look like when we run that code? It's ID. We call this string type. Let's call this one. I'm going to delete the top one. Then put this one as equals to. Then the next one is what? County ID. County ID. We pass in county ID here. We go forward. We call the next one middle age. Middle age is, in this case, is not, middle age is number, right? So we're going to change this one as what? Let's call it long. Long type. And we have, after middle age, we have what? Again, adult thing. So we have to account for that. So we can copy this field again up to this. Copy, comma, repeat. And that is after middle age is what? Adult age. We'll go again after the true, comma, paste again. After adult age is what? Teen age. Because they are the same, but we're going to adjust the data type. Okay, so the data type is correct because we need long now. So after this, we have young, comma, let's put young there. Young people. Now, young people. Now, we've gotten this right now. So if we run this now, let me just put this one as, I will comment this out because we don't need it. So if we run this now, good, and let's run this. Can you see? And now if we run this now, what will happen? Can you see it? So it's saying the county ID is what? String. Okay. County ID cannot be long type. Can you see? Because it's a mixture of alphabet and character. So this one has to be what? A string. Does that make sense? So if we run it, we capture it correctly now. Can you see? So we know the actual data type because it's a mixture of alphabet and numbers. So it's a character, so we can classify it as string. And now we've been able to pass in a new what column, and we defined the data type that we're interested in. And if we do no header this dot print schema, then we will see our data result. Can you see? It defined this one as long, 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 and this one as string, string. So we have defined the schema of our data. We have assigned the expected column and their data types. Does that make sense?
Yes.
Thank you. Brilliant. I think we've really gone far. So we're going to do a few things also. Like I said the other time, I said Spark data frame in the beginning. If you remember the beginning of the class, I mentioned something about like a manager. It's like you have a manager at work, and the manager is now assigning tasks to other people under him, to people under him. So to make the work faster, maybe we have 10 people under him. Maybe if the manager is doing the job by himself or herself, he or she will do it in 10 hours. Now, he or she decides to now assign it to 10 people. How many hours are they going to finish the task? How many hours is it going to take to finish the task?
1 hour.
1 hour or
1 hour.
less.
1 hour. Thank you. 1 hour. And the reason is that normally the manager, if the manager is doing the job by himself or herself, it's going to take him 10 hours, but you have divided it among 10 people, and it's going to take 1 hour each. That is where the aspect of the parallel distributive process of Spark comes in. So it's like dividing the task among different people to get it done within a short period. So Spark is is faster. It's faster than when you're using Pandas data frame. Does that make sense? You see, they look similar, they do the same thing, but when it comes to Spark, it processes your data faster and it deals with large amount of data. Not that Pandas data frame is no good, but when data are getting more larger, bigger, and bigger in petabytes, in terabytes, it's going to be difficult to start managing that data. So most organizations now are trying to scale up, trying to introduce Spark into the environment. And Spark is a bit dynamic. You could load data from Pandas data frame to Spark data frame. You can do Spark SQL like your normal SQL query for ETL process. You can use RDD, you can use Python, do transformation for loop within the Spark itself because it's a combination of Python and Spark. And don't forget, Spark is not only applicable to only Python, it's also applicable to Scala, Java, R. So it's very flexible and dynamic. So in this class, we are only focusing on the Python Spark part of Spark. So now you've seen the result. We've been able to assign a schema to that data, and we've been able to print the result. So we don't need this anymore. I will comment this out. So, the parallel processing, how do we now know how the Spark is able to handle this data? Let's check. And that brings us to something called repartitioning. Repartitioning. So let me do repartitioning. So let's check our data. Let's check. Now, we have our data, no either data frame. We can apply RDD dot get number of partitions. We want to get the number of what? Partitions in this case. And let's run this and let's see our result. Oh, it said 1. So this requires only one node to process this data. It requires one node to process this. Now, can you see? So it means it requires only one person to handle this task. But it's possible you might decide to okay, this data, why can't we just assign more people to do this task? We could do this and apply it from here to process the data. But I'm not talking about the other part. I mean, when you're trying to, let's say, for example, you want to store this data in a directory, we could decide to do df no header, df no header dot repartition. We want to repartition this data. We want to decide how we want this data to, let's say I want to do three data. So repartition this data. Okay. And let me do data no header dot write. Let me do CSV. Let's see. Oh, sorry. Okay, let's see what we have here. Data class. How many files do you have here? Let's see what we have. So it's splitting it into 2 files only, maybe because of the capacity. So now, because we mentioned 3 here, so let me delete this back. Let's see what we're going to have. I'm going to delete this file. Oh, it's not empty, so let me delete this. Okay, let me see if it's going to go now. Okay, it said it's not empty, so let's keep deleting that. Delete. Delete. I hope it works like this. So now I've deleted that. So let's run it again as 2. Let me say 2. So let me save it again. Let's see. Oops. Already exists in that part. So let me just do 1. Okay, let's do it. So it's saving as how many files? Oh, data class 1. Sorry, 1. This is the one. Can you see 2 files now? So I think the maximum division this can do is 2 repartition because the file is not that big. So it's like assigning 2 nodes to process the data, while we have the master node, which is the manager assigning the task. So that's what is happening behind the scene. So that's how it works. And one advantage of using repartitioning is that it helps you to quickly load your data into any directory that you are trying to load, save it under. And repartitioning can, if you make more, if the data is very big, you could maybe divide your data into like 10 repartition, but it goes with a cost. So in an interview, you could be asked that what's the difference between repartition and coalesce. So repartition helps you to process the data faster and split the data into different files, CSV file, JSON file, depending on what you are doing, or packet file. While coalesce helps you to combine all the files together. So repartition is faster, but it goes with a cost. While coalesce is it compiles all the file as a full file together. It's like the manager is the only one doing it. Now you see the difference. It's like one person is doing the task, so it's going to take more time to quickly save that file into a directory or a destination, which means it will save the organization cost. Imagine you have a manager and you have 10 people under the manager. Automatically, you have to pay the 10 people, right? But in the case of coalesce, let's say you have one person. You could also assign 2, but you can use coalesce to reduce the number of partitions you have. Maybe from 10 partition to 2 or just one full file. That means one person is responsible for the file, and it's going to be a bit slow, but the cost will be a bit low when it comes to effect on the organization. So now let's do. Now we've been able to do repartition this, and let's convert this one to coalesce now. So I can do no header, df no header dot coalesce, and let's say one full file. I'll call it 1. And if I do, let me do this one as 1.2 as a new file name. So I'll do this. Can you see? And when I run this now, the file will be saved. And when it's saved, it's going to be one file, single file. 1.2. Let's see. Oh, it's still too simple. I don't know how it's done that way. Did I make any mistake? Okay. So I don't know what's happening there, but it should be one single file. So that's how it works. Also, let me just do, after applying that, let me see what is happening behind the scene. Let me do df underscore no header dot rdd dot get num partitions. That's one, so it should be one, but anyway. So can you see it's converted to one? But initially, if we test for this, if we test the same thing for this, it should be two. So yeah, but it's still capturing this. So that's the idea. So now I've shown you few steps here. I think I jumped steps. Can you see I've even covered this area now? So I've covered this area. I think we are done with this part of data engineering. So I will continue. Do we have any questions so far?
Yeah, the question I want to ask is, we've done repartitioning and collects. Under what circumstance? Because we are not applying it at the moment. We are just looking at what you're doing.
We
But under
applied.
what huh?
We applied.
No, under what? Okay, let's say under what circumstance? Say, for example, you have a data frame or you have a data. Under what circumstance do you now say at this point we do repartitioning or we do collect?
Brilliant. So for you to do that, you remember I told you the size of data is very important. Remember, we're just using just little size of data, small size. So if you are talking about petabyte of data, let's say you are working in Facebook, imagine the data you'll be generating in Facebook across the world. How much data are you going to be talking about? You understand? Data size on Facebook. Let's see if we have, can you see 4 petabytes of data per day? Does that make sense? So I say it scan, yeah, Facebook generates 4 petabytes of data per day. So that means in a week you are generating like almost 28 petabytes of data, if I'm correct, or 30. Does that make sense? So, but our data is just kilobyte. Maybe that size of data is kilobyte. So in this case, you will know the data is very big. So you will require like repartitioning or coalesce in this case. Maybe repartitioning just to make sure that you split the data and save it. Does that make sense?
Yes.
You understand? Because of the size of data. So when it comes to Spark data frame, I mentioned the size of data. The size is very, very, very important. You understand? So in that case, you apply repartition depending on what your organization wants. Don't forget, if they want data to be processed faster, it makes sense to use repartitioning. If they want data to be they don't care if it's going to take time they just want a whole full file. And you know that the file will be divided into sections. Just use coalesce, capture the file as a full file, and that's it. So depending on your organization, what they want. Now, so that's an example. So we're going to focus now on data transformation. You've been doing, adding schema. We have not really gone in depth to Spark, but we're going to continue with what we call function. Function in Spark. I will check if I have it here. Can we have like maybe a short break? Then I'll need to pull the file just to make sure that we manage our time better. Then we continue From there, we're going to have oh, sorry, I was talking. So I didn't know that I muted the. Can you hear me now?
Yes, sir.
Sorry, I was talking.
Yes, we can hear you now. Yeah.
You can hear me now. Okay, thank you. So I said we have functions, we have series of functions called select, we have with column, we have with column renamed, we have count, we have filter, and I think that's all for now. So please just stick to these few example functions for Spark data frame. So we'll be treating each one after treating them one after the other. So I'm going to start with select. So we have our data frame. I will go for, let's say we start with no header, right? Remember we have no header. We generated a file here. So I'm going to take this off, not to confuse you. So we have no header, no df underscore no header data frame. So let's do df underscore no header. Let's say we want to select. So we can do df underscore no header, df underscore no header. We just do dot select, right? Data frame, what's the column? What column are we picking? I think we have candy there. Let's say we want to pick the candy only. And that's it. We run this one. If we run df now, we've generated a new column called, can you see? Dot show. Let me do dot show. Dot show. Can you see? So we have this as the new column. So we are extracting candy as a column from data frame, and we are getting a new column called candy only. Does that make sense? It's just like your select statements. So if I want to capture more, I can go here and capture other columns that we have. What other columns did we add here? We added country ID and middle age. So let's do it. Let's add it here. Country ID, comma, and middle age. So let's capture. Let's
So
run
can
it.
we use to capture everything, please?
Yeah, you can capture everything. I think I've shown you that already. I've shown you capture. You don't need to capture everything. You've already captured everything here. You remember?
Yes, sir.
Yeah, what I'm trying to. Oh, okay. Let me do this again. You remember this file? We're passing a file path now that we created, and we got this, right? So I'm using the same file, df no header. Okay, let me just change the name. Let me change the name here now. Let's say I'll call it df. Okay, so df. Okay, so in this case, I'm using df. Forget about what we have there. So let's focus on this now. df. Sure, is the old data, right? So if I want to um also select all the data, I can do select all. Think if I'm correct. Let me see. Mhm. So can you see? No. So yeah, that's perfect. But it's a long story. You don't need to stress yourself. You understand? df the columns don't show. It's still the same thing. You don't need to waste your time doing select all. You understand?
Yes, sir.
Yeah, because it doesn't really make sense. You already know if you do df dot show. So why do you need to now be creating dot columns? You understand? It's not necessary. To me,
Yes,
I
sir.
advise when you want to use dot column, you use it in different situation. Let's say, for example, you want to, okay, let me give you an example. We've done this before. If you remember, when I was talking about length, let's say you want to capture the length of the column, number of columns that you have. That makes sense, right? That's 6, right? Because we have 6 columns, 1, 2, 3, 4, 5, 6. You understand? And the reason why
Yes, sir.
sometimes this is very useful to use dot columns in the sense that you might have some data where the columns might vary. That's a complex data, isn't it? Let's say, for example, you expect this data to come with 6 columns, and suddenly it changes to 7 columns or changes to 8, and you want to capture it. So, trying to emphasize that, okay, this data will come as 6 columns, you know what to write. And that comes with the conditional statement. You remember a conditional statement? If length of this column is equal to what? 6. You understand? Do this. Let's say you want to do data frame this. Else. You understand? Else. If you understand, if length of this equals to you understand what I mean? So you want to capture, let's say you have a complex data entirely that the columns they keep changing. Maybe in this case it's 7. You understand? Then
Or
you do,
greater than 6.
yeah. I'm trying to be very careful. Let's say, for example, we only have a situation where it is 6 and 7. So you can say equal to 6, or maybe in this case greater than 6. But if it's more than, you can't state only greater than. Or you could do it and also say if length equals to this data frame, transform this maybe data frame dot whatever. You understand?
Yes, sir.
Then if length else if or else if length is greater than 6, then you go to the next line. Maybe the next line could be uh else if this, then you go down again and start writing other conditional statement to capture maybe for 7, 8, 9, 10 if it keeps changing. This is a complex transformation, but I'm trying to give you an idea of how to approach data where the schemas, the data, the columns keep changing. So you have to create a conditional statement and start doing the manipulation separately. Maybe, for example, the data comes as first one is county ID, middle age, adult age, teenage, and young people, right? Then the next one comes with this in addition to other two columns, and you don't need those two columns. You know what I mean now? So in that case, what do? You capture it, you delete the two last columns, and you append all of them together. Does that make sense?
Yes, sir.
I wish I could
Yes, sir.
give an example here, but it's going to take our time. Maybe I will give you as a project. I think this is a very good one for a project. So what we do is that I will expect you to load like data, like data, um, data frame. You understand? You load data frame. Let's say, for example, yeah, I loaded no header. So in this case, we are going to create maybe UK data new 1, 2, 3, 4, and you copy the paths. You read all the path, and you read the data frame and check which one is the additional columns. Then you delete it and you append it and you save it back. I will give you that one. That's part of the project. So be expecting that at the end of the class. So I will create like 3, 4 different files with 2, 3 different additional columns. And I want you to capture only maybe a specific columns in this case. Then you append them together and you save it. So at least we can start from there. You know how to dynamically grab files if they are changing, if the schema is changing. Does that make sense?
Yes, sir.
Yeah.
Thank you, sir.
You're welcome. So you see the example when you are using length. You see length is very useful. You remember when I was talking about Python? So you use this length, you check, you read the columns. This is going to capture all the columns. It's going to read it for you. Then you did the transformation. If the column is changing again, you quickly use this one to capture it. If it's greater than 7, write another something to capture it, transform it. Maybe it requires you to drop other columns, do it. And that, sorry. That's how it works. And now, so I've explained the select now. I think select took us to this. So we don't need this now, but based on the question you asked, I was forced to explain that. So now let's go to the select now. So data frame, let's call this one data frame and do df underscore df dot select. And in this case, we are selecting, let's say for example, we want to select only county ID. It's giving us the whole data. Now let's say we want to select only this. Just do this. When we run it, you'll be able to capture that. You see, I'm changing the variable name. You can use any name. I can use your name and maybe add it to it. So if I do this one now, df does show, see the results. Can you see? We're only capturing only few columns. So we're creating a new data frame from an existing data frame. Does that make sense? Okay. So let's go to another one. Let's say, for example, I want to do, we have other ways to select. I will also maybe show you other ways to select. I think it's better I just maybe show you other examples of selects. So other examples of selects will require you to modify this select in a different way entirely. And how do we do that? Like you said, select dot columns, which is good. I love the suggestion. But now we select only, here we selected 3 columns. But what if we want to do it in another way? Let's say df1 again. I'm showing another example. Or let me do it this way. I think it makes sense to show you an example this way. dot show so that will not alter anything. Dot show here. Does that make sense? I don't want to be altering data frame, so I will try and adopt this method. So now, what if we want to do another select, which is we are using dfdf, don't forget dfdf. I want to select in another way, then I can do dot select and do df underscore df like you said the other time, dot columns, right? Then, and let's see the number of columns we have to capture. Remember 0, 1, 2, right? So let's say we want to capture up to this, and let's do dot show. Can you see from the stats then to column what? Can you see? So you could maybe use this one also. You remember our list. If you remember all this, can you see that I'm applying it now? I'm applying it. I keep applying all what we've learned. The first class when I introduce you to list, tuple, all those stuff. So I started, can you see? So I'm capturing it now, passing this, and I'm grepping the column. We have other ways of doing that also. Select. We could also use df dot select then df underscore df dot, what's the column name? County ID. County, can you see? Comma, df underscore df, comma, df underscore df dot county. Let's say I want to choose ID, then comma, df underscore df dot what's the name? Middle age, right? Dot middle age. Brilliant. So I can do this and do also apply show. I will still get results. Oops, something is happening here. I think there's a mistake here. Let me see where. I said there's nothing like can't see ID. Did I make a mistake? Can't see underscore ID. Can you see underscore? I think I made it. So underscore ID. Can you see? It's still the same answer. I apply select this way. I applied select using the what we know about slicing, and also apply select this way. They will all give the same result. So you can use any method to do to do selects. Any question? And don't forget, this is also the same as when you are writing 0. You remember? This is same as writing
Yes.
0.
Yes.
Just want to point your attention. So if I take this off, it's still going to give you the same result. If you put 0 here, it's saying from index 0, which is the first column, to what? The index 3. Sorry, 0, 1, 2, 3. You remember when you are doing list, it's not going to capture the last one. So it's going to do 0, 1, 2. This is 0, 1, 2. That's the meaning. And that's why we're having this. So now, we've covered that. I've shown you this an example. Then let's go to the next one is for us to start using with column. So I'm going to use df underscore df again. So we can use df underscore df with column. Let's say we want to create a new column. Let's call it I'll call it county ID, right? Let's say county ID split. We want to split that county. Yes, county split. Let me call it county split. Okay. And I can do df underscore df dot county
That's no underscore. Dash.
Oh, yeah, dash. Sorry, that's a mistake from my side. Underscore Kanti. Let me see. Dot split. Hmm. Me split by, so by space, then let me capture one, and let's do dot show. Let's see. So he's saying, let's see, he said that it's nothing like Kanti here. So Kanti, so maybe there is a mistake somewhere. It's Kanti, that's uppercase. Does that make sense? So it's not saying it because of the uppercase. Let's see. So column this is not callable. It's not callable. Let's see where we're making. So in this case, what we do is I could maybe just create something here. Okay. Let's say. Okay, that makes sense. So let me do.
I'm thinking of something, sir.
Okay.
Yeah, can we split by underscore? Maybe that's good.
Underscore. Okay, let's try underscore. Let's try underscore. Let's see. Say column, this is not callable. So
Okay.
let me do 1 second. Let me do notes. Can't see. Okay, let's see. Okay, it's not callable, but wait 1 minute. Let me see if this is gonna work. Split file. Let's see. Data frame. Data frame. Okay, data. Let me just use data value equals to for I data value. Okay. Brilliant. So data, find data, sorry, data split equals to I dots. Oops, I dots. I will explain this. Just want to make sure we split the file properly. Split, okay. Okay, 1 second. Split out. Let's open. Splits. So let me add data split. So split add. Okay. Sorry. Split and split file. Oh, sorry. Split file. I'm gonna take this off. Press this in. Let me see if this is gonna work. Okay, it's still asking for column is not iteratable. Let me see. Did I make a mistake somewhere? What could that be? Column is not iteratable. Okay. Okay. But there's a mistake somewhere. But we can use function to quickly, transform this data. But Let me see how to deal with that. I'll find a solution to this later, but we can decide to like split that data. Let's say an example. Let's see split column data frame, Spark data frame. That will give us example. Most of the time you also need to use Stack Overflow. And you see saying, okay, this is Lambda. They're using Lambda here. So which is also okay. Let's see. Split. Okay. Okay. Let's see an example here if you have a very good example. Okay. So it's using a function called, okay, 1 second. This is not a typical good example. I'm just thinking of one example to use. Okay, so let's leave that split so that it won't take our time, but I'll come back to that. So let's say, for example, now I'll come back to that. We're going to treat it before we end the class. So let's say, for example, let me run this and keep this record, then we'll come back to it. So let's say, for example, we want to add a new column. Let me copy this. So we want to add a new column. Let me use this, let's say can't add. Can't add. We want to add this. So how do we add this? Let's say, for example, we can also use something called concatenation. They call it concat. But we can't use this concat without importing the library concat. Does that make sense? So we have to use, can you see, say concat is not defined. So we need to actually define it. So what we want to do in this case, we have to import from PySpark dot SQL dot function. If you are not clear about maybe something, like a concatenation you want to know, just do concat Spark data frame. It's so easy to do. Grab concatenation there. It will tell you what to do when it comes to concatenation. Can you see? It's saying, okay, let's see if it's going to give us any reliable answer. It said you can use this for leads. Okay, we can use leads. Okay, let's see if this is going to do work. So let's go back here. Import from PySpark.sql. Oops, sorry. From PySpark.sql. Okay, the SQL function imports leads. Good. And comma concat. Concat. Let's see if concat is part of it. Can you see concat and split? Oh, I think it has split. So split is going to my work in this case. So from PySpark. Oh,
you have F at function.
Thank you. Thank you for spotting that out. So let's see that. So we want to concat now. So we are applying concat now. So can you see it's not saying it's not defined anymore. So we've been able to pick that concat. And we have Canty. So let's say we want to add Canty with Canty ID. So in this case, we could maybe say we have a new column that we want to create. Then we have the existing one. Then we can do, let's say we want to add lit as a function. And what do we want to add to that? Let's say we want to add, let me see. We want to add dash dash to that. Want to add dash dash. So which column are we using? We are using df underscore. Let's say we are using Canty ID now. We want to add it to this. So df underscore this column We are using Kanti underscore ID in this case. So let's see our results. Let's see what's going to happen. So what we have done here, we are creating a new column. Like I said, with column helps you to create a new column or do any other transformation to create a new column. So here we are doing transformation by joining two columns together. We are joining them together to create a new column called Kanti add. So let's see. Can you see? The dash dash we added to it is showing. Show equals to just want to show. Okay. So now can you see Kanti Durham, which is here? In addition to this, we are joining them. So if I decide to remove this one, and let's say I'm using space only, it will generate, can you see, space, joining them together. Does that make sense? So that's how it works. If you want to maybe make few other research, let's say, for example, we want to apply splits. Let's see what is going to happen with splits. Splits columns. Make some search, Spark data frame, because we have not used it in this case. So let's see how it's going to work. So it says split columns. Okay, let's see. Let's check from our, I prefer to use the Apache Spark platform. Let's see the documentation here if it's going to give us something sensible. Okay. Okay, so you see different functions there. Split, see split is here. So you could use maybe go for this one. So, but in this case, we've finished with our leads. We've been able to join data together. So maybe we could maybe also use other concatenation, other part of concatenation. So just practice, I will advise just practice this concatenation, use another way to concatenate in case, let's say, I don't even want to use this one now. I want to maybe concatenate with, let's say, for example, I want to add this one here and comma. 1 second. So I want to do comma with add. Let's see if we have a result. Can you see add is added? So I can decide to do this, put it here, this, and it's going to space. Can you see add? It's been added to everything. Or if you like, you can just put underscore here. Run it, it will generate a data with underscore, underscore, underscore. Does that make sense? Does that make sense?
It's becoming a bit confusing, but I believe if you go
complex
practice, yeah.
Yeah, is the concat. You see, we are importing from this library. Remember, I told you module, lit, concat, split. So in this case, we are using lit and concats. So we're just going with column. Let me explain this with
What
column.
is delete there now? What is delete?
Delete. Where is delete?
No, lit. You say import lit.
Lit is to join.
Oh,
it helps
okay,
you to add the new column. If you want to add
Okay.
code, sometimes in your data, you might want to, let me delete this one now. Let me take this off. You might want to add code a value. Sometimes we add code a value. Let's say, for example, I want to add code 1 to this now. If I run this one, concat. So sorry, let me take off. We don't even need leads anymore. So I want to add code this leads 1, and I want to create a new column called add. Can you see? 1. So use it to create add code values. So here, I've been able to create a new column now using lit. Can you see lit helps you to add code? So if I want to add code United Kingdom here. I'll just pass here. I'll do United Kingdom. And that's it. Can you see United Kingdom? So lit is a function, part of this module, that will help you to what? To do hard coding. But you remember, I use concat to join two together. Does that make sense? So if I want to join this with this with United Kingdom to create a new one, I can do that. That was when I use concat. Does that make sense now? So concat helps you to join. Okay, concat now. Let's say we want to try concat. Now I've shown you an example of creating hard coding. So let's say I want to concat now. Then for concat, I want to add df underscore df. That's the first column, which is the county, right? That's county, comma. So I want to concat this now. If I run it, you see this one will change. It's going to combine this one with the United Kingdom I'm adding. Oh, there's a mistake somewhere. Saying concats. Okay. I made a mistake, sir. Let me leads, okay.
There should be a comma somewhere.
Yes,
Check
that's what,
after with column. That comma is not
with column.
at the beginning. df underscore df with column. That comma, the open bracket is red. Shouldn't be.
Oh, this okay. Oh, this one. Yeah. That makes sense. Correct. I think this is where the. Oh, brilliant. Thank you. That's it. Can you see? Thanks for spotting that. You're a good data engineer. So you see, we've added United Kingdom. If I put space here now, it will give me space here. Can you see? United Kingdom, United. If I put dash here, it will give me that. So you see, initially we just hard coded with lit, but now we are concatenating, we're joining this with the new hard coded one to generate this. You see, we have applied lit, we have also applied concats. Does that make sense? Any other question? Okay, so we're going to go to with column rename. So I've given you an example of that. Please keep practicing this. Let me see if I can do any additional one also. Let's see if it's gonna work. Conti add age addition. Let me do age addition. Age addition. Let's see. Let's see if this is gonna work. Sometimes you need to try something as data engineer. Try different method and see it's gonna work. This goes with this. Can you see? I created age addition by using the data frame middle age. I'm adding it to teenage, right? And it's giving me the results. Does that make sense? So I'm still using with column. So I'm using it to, that's why I say you can use it to create a new column by doing multiplication, division, addition, or concatenation, wherever. So you do that. So new age, I can do new age now. Age, I can do middle age, maybe middle, just to make it middle plus teenage. Teen age. Yeah, can you see the result? middle teenage. So I'm adding middle age plus teenage together to give us a new result. And if you check it, it's correct, it's accurate. 16,869 plus 17,800 is 33,000. That's the answer. Does that make sense? So that's how it works. So I've given you different examples of column with column. So I'm going to go to with column rename now. df underscore df dots dot with column rename. For example, let me use this one as an example now. I'm not going to go that far. So let me see if it's going to work. So we have with column. So I can do with column rename at the back. Let me remove this show. It's column rename. Let's say, for example, I want to rename County, right? I want to rename County. So the column I want to rename, that's the current column, which is County. Let's call it County. Or let's say middle age, let's say the new column that I just created, middle underscore teen age. I just created this column. Then I want to change it. Then I can do updated name. So I'm coming. Let's see. Can you see now? Does that make sense? You see, when I added it here, let's say I forgot to change the name, but this is the expected name, updated name, instead of middle underscore teenage. Here, I added with column name, the old column, which is middle underscore teenage, and I change it to updated name, and I show the results. Does that make sense? This is with column. So if I don't want to, sorry?
Yeah, it makes sense.
Exactly. So if I do, if I decide that okay, I don't want updated name, maybe I plan to I have intention of naming another column. Let's say for example, I want to name County. I want to name County. I can name it to County, United Kingdom. And I run the show. Can you see? It's changed because I renamed it from here. Old name to new name. Old name to new name. And I've been able to do that within this line of code to capture that. And so now I've shown you an example of that. So that's renamed. You can also do another one called, let me see the other one that we talked about. We talked about rename count and filter. You are all familiar with count already. So count is not new to you because we can just do for our counts, we can do df. You're already familiar with that count, and you can maybe use counts. You understand? Or sometimes you might also need to use maybe group by when you are doing counts. It depends on what you're doing. You use maybe group by, then you do counts. You can group by in your data, group by, and you do counts. So now let's apply filter. I will apply filter. So let's say, for example, we have, okay, let's say we have this column that we have created. I'm going to use this one again. I don't want to be, okay, this count is okay. Let's say we have this column. We have created this, which we are all familiar, and we want to filter. You can apply dot filter at the back, or in this case, let's just not make complex. Let's say new data frame, right? New df underscore df. Let me call it new df, and I will remove this. So this is it, right? Now, and if we show this, remember it's not having show. Show is what is displaying it. So I remove show to create a new data frame. So new df, if we run new df underscore df now, the show is going to give us this. So now, which is perfect. So we want to now filter. So how do you filter? We just use filter, right? We can do new underscore df underscore df. We can use this, as usual. I told you different way to select. You can do, let's say we want to do middle teen age. Is it middle teen age that we use? Middle teen age. This is the column at a point. So we want to filter by, let's say, where this is less than 1,000. Let's see, do we have 1,000 there? Hopefully, let's see. Then we apply dot show at the back. I can decide not to apply show if I don't want to show here. Then I will just move back. It will force me to be creating another data frame. So where we have less than 1,000, what do you see there? Mid age is what? 707. We only have one. So here you can apply counts. So counts here means counts where we have less than 1,000 is going to give you one. Does that make sense? Because we can see it when we apply show. It's only one. So you are applying two different functions. After filtering, then you do counts. So that Spark data frame is very good. You see, it's similar to when you are doing also counts in your SQL. So it's similar. Filter, you know how to filter, select where this is, this, you filter. It's still the same thing. So it's so easy and very, very friendly. Very easy and friendly. So you could also filter by maybe two different options, like two different columns where this is this and this is this. Let's say, for example, we copy this one now. I'll go to the next line. Filter this where middle age is this, and we can do and new df underscore df. Let's use middle age middle age is, let's say, greater than, I don't know, let me just do 10,000. Let's see if it's going to give us results. So we are filtering by, so it's saying, oh, there's an error somewhere. Oh, makes sense. Yeah, so there's an error here because I need to capture this separately. Because we are combining two together and this. Can you see? It says empty, so there's nothing like that. If we apply counts here, we should be expecting what? What should we be expecting?
Zero.
Zero. That's it. Zero. Can you see? Zero. So that's so we're trying to do when this is less than 1,000 and this other one is greater than 10,000. So let's see, when this one is greater than 1,000, we should have a value, right? Let's see. Can you see? Lots of them. And when we do count, we apply it, we have what? 310 values. So that's how it works. If we change this one again, maybe less than 10,000, let's see what we have. It's saying 11 because of this, because we apply less than 10,000. So we have applied filter, we've applied can't. Which other one do we want to do? Did I say so? Filter. So we've done filter can't. Let me just maybe try few other functions that we add that. Let me do. Let's try start with. Start with. You are familiar with this in SQL also, so it's not something new. So start with. So if I want to use start with now, I can just go to this. Let's say, for example, I can do new underscore df dot filter. So when you are using this, you use filter also. Filter, let's say new underscore df underscore df dot. Remember the select. So I'm going to change my style of select now. So I'm going to do dot country underscore United Kingdom. You remember we changed the name, then we can do start with. Start with. Let's say everything that starts with, let's say I or IN. Let's see if we have IN here. Start with dot show. Can you see that it's nothing starting with this? Let's say if we start with I, we should have a lot of I. We have I, right? Because it starts with I. We can also use ends with too. This is start with now. We can do ends with. So which one starts with A? Let's try A. A, can you see A? A. So this will help you to select data also. It's really, really, really good to adopt understand how to capture data. Sometimes some data might not be that straightforward. Look for a way using start with, end with, this and that. It will really, really, really help you. So now we have ends with too. Let's copy this one. We can do ends with, ends with, ends with. Okay, so let's do this. Just change this one to ends, ends with. So if we end with A now, let's see. There's nothing here. So let's say ends with E. Let's see if you have a result. We've got lots of them. They end with E. Can you see E, E, E? For that column, don't forget it's county. We are filtering based on county United Kingdom, which is this. So we're checking ends with E, E at the back, E, 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 E,
Sorry,
E.
sorry. Will it make a difference if you type the A in smaller case?
Ends with what?
The ends with A, you went ends with A. It's
Oh,
used
ends
a
with A.
smaller
Yeah,
case.
yeah, we can
In
use.
smaller case, yeah.
Yeah, let's see. Let's see if we have. We have South End C. Can you see? And this other
Yeah.
one. Yeah. So show. There's a way we can. Let me see. I remember. Let me just show results. So this one should be come full output. So this should give you show all equals to true. Coming. Forgotten that line of code now. But I want to show the whole result because this one is not showing. So let me see if it's gonna pop it up. Show. No. There's something called, I've forgotten that something, but you can pass it in here and it's going to display the whole results as in here. So you can't see, but it does not matter. It's just for show. So now you see start with, ends with, and we can see the results. We have something called contains too. Contains. There's another one called contains. Contains, if it sees any, anything related to something, it's going to change it. So let's say contains. So let's say we can pass in contains now. Okay. Let me do contains. So if I run this one, I'll put contains. Contains. If I run this, contains anywhere with A. Can you see? It's different from one ends with is 2. When it contains, whenever we have A, let's say contains Z. Let's see if we have Z. Z is not common. Contains Z as a capital. Nothing. Contains Y. Can you see? Contain X. Nothing. So contain S. This should be common. Can you see we have more? So you can use it. Contain, it could be any point. It could be at the beginning, in the middle, or at the end. It does not matter. That's for contain. But for ends with, it must be the end parts. Does that make sense?
It does.
Thank you. So, okay.
Yes, sir. Can we do ascending order and descending order as well?
Yeah, we can do ascending order, descending order. There's another one called like. We can do ascending order and descending order. So we have something called like. It's in fact, I love this. This is one of my favorites. This like is very, very, very important. I've used this several times. So like, let me copy this. I don't want to keep typing. It takes me time. But please, you can type. It's good that you type. So like, you just pass in like here.
Sorry, while you're doing that, I know you keep saying, you don't want us copying, you don't want us, is there any particular reason you don't want us, copying and pasting?
So that you can learn faster. If like me, I know what I'm doing. But if you keep copying, you won't be able to trace error easily. But if you are typing, if you are making mistake, you will trace it. It will help you. It will immediately you are typing like this. You just pick up that there's a mistake somewhere because you've made the mistake several times and you know how to fix it. But if you copy and paste, you think that it's so easy like that. You will not understand what is happening. You will not understand the code clearly. But it's better you type.
Thank you very much.
Okay, you're welcome.
Yeah, it's fine.
Yeah. So now if I add percentage now, the meaning of this percentage is when you're using like anything after A, before X. It could be anything before X. It will capture it. But after this X must be the last. Does that make sense? So this X, if it's going to capture anything now after this X, there's nothing. It must be S. S must be the last, but anything before S, it will capture it. Let's see it. Let's see the result. Can you see S is the last, but anything before S is capturing it, wherever it is. Does that make sense? Okay, let me apply this to counting ID. Look at this EO6. I think this is a very good example. EO6, EO8, EO7. Let's say as a data engineer, you're expected to capture only EO7 and they all come with E. Okay, So let's see what we can do. So we want to capture EO7 only. And what's the name of that column? County underscore ID. So we're going to change this. County underscore ID dot like. Okay, I'm going to take this percentage of EO7. What is after EO7? We want to capture everything after it, so you put percentage. What do you see? Everything EO7 is captured without EO8, because you said anything after EO7 it should capture EO7 and any other either character after that EO7. So it's going to capture. This is very, very useful. I've used it several times to solve series of issues when I was transforming data. So this like is very important, and you are familiar with it in SQL also. Like. So now, there's another good thing about Spark is that you can use Spark SQL, like I said. So let's say we have this. We can create data Spark SQL from here. So we can do, let's say, create or replace temporary view. This is very good. So we pass in the temporary view. We can call it, let's say we call it, let's say we call it SOM class 18. Okay, it's giving me that option. That's good. So if we call it SOM-18 now, remember these are a data frame. So we are creating a view, a temporary view. You know what temporary view is in SQL. So I know you are very familiar with temporary. It's not a table, it's a view that is being stored in memory. So now let's go down. And if I want to query this data, I can just do our Spark that we uploaded, spark.sql at select all from SOM class. And we can do dot show, and that's it. Can you see? You can decide to query further. Select, let's say for example, select your SQL. You can do select county. Select county. Is it county ID? County United Kingdom, county United Kingdom, comma, not again.
Underscore United Kingdom.
Thank you. Underscore United Kingdom. County underscore United Kingdom. Oops. United Kingdom, comma, this middle age, comma, let's say middle underscore teenage from SOM class. And we'll go down where county, where middle age underscore age is greater than 16869. Let's see. Can you see? Does that make sense different from the SQL that you're familiar with? It's not different. And if you like, you can just do maybe order by order by order by order by middle age. Let me see if I'm not making any mistake here. I'm not sure if I make a mistake. I think there is an error somewhere. Oh, because of this. Can you see? So because of this, order by middle age. Oh, okay. So it's saying there's an error somewhere. Order maybe for my order by. Okay. Can you see? Is there any different from the SQL that you know? So from here, you could maybe do wherever you can do a lot. You can do a lot and lot and lot and lot and lot and lots and lots. You know, Spark SQL, it gives you opportunity to play around wherever you want to do. Am I making sense? Can
Yes,
you
sir.
see how they are all connected together now? Spark SQL inside Spark, Python inside Spark. We've touched the two, and I told you how did it to data frame. The only thing I didn't cover is this pandas to data frame. And if we have a panda here, we can also see an example. And that was any question? Any question at all? So you can also read, you can read data in pandas data frame, like I said. Let's say, for example, now, import pandas. You are familiar with this already. So pandas as PD. If I run this one now and I can do pandas underscore df equals to pd dot read underscore csv equals to, so let's say we want to read, what's the file that we have here? Let's see the file. We have this copy path. Let's go here, pass it in, and read this our data. Can you see? So this is the pandas, right? If we read this data in pandas, can you see? This is the data. So our df, right? df, which makes sense. Then let's say we want to convert to pandas, just to pandas. So we are converting our Spark data frame now that we have already here. df. Oh, okay, let me call it new df, new underscore df. Then I'm applying pandas data frame. Let's say new panda now, new panda. So if I do this and I run this, good. I've converted our Spark data frame to pandas, and I can read it as what? Panda. Oh, it's going to give me a something. So can you see? So it's turned to pandas data. Can you see the format of is a table structure? Can you see? That's the format of pandas data frame. Does that make sense?
Yeah, go on.
Okay. So, any questions so far?
Yes, sir. Now, how we change this pandas to PySpark?
Okay. So let's see what we can do. So pandas to PySpark. Pandas. So it's 2df. Let's do to PySpark. Now let's see an example here so that you can see. Pandas. I think this is a relevant document. So pandas to PySpark. Let's see an example here. So that should give us create data frame. Can you see? You use the create data frame. Does that make sense? So we can go here and do pandas equals to spark dot what creates data frame. It's giving me now.
So can we make it another code and leave this one there?
Which one? Sorry, I didn't get
Like
it.
instead of make it the next line 182 instead of tampering with 181.
Oh, okay, that makes sense. So, converting pandas. You remember create data frame that I taught you in the beginning, pandas
Do
to
it below the pandas table so that we don't lose that information.
you can't lose it.
Okay.
Yeah, it's correct. Oh, under it.
Under the table, yeah.
Okay. Let's do it this way then. Let me do next line, new pandas. Run. Can you see the result of pandas? So here we're converting pandas to Spark data frame now. That's Spark new panda Spark. I'll call it new Spark panda Spark. Run this one, and that's it. Now we do new panda dot underscore Spark dot show. And you see, I told you we used to DF. The other time I used to DF, it didn't work right. I should have passed. What I should have done is to pass in the data frame. You understand? So, but in this case, I did spark dot this, and I pass in the pandas data frame, and this is the result. Can you see? So you can play around from spark to pandas data frame, from pandas data frame to what? Spark data frame. So I've shown you an example of SQL. I've shown you an example of Spark data frame to pandas data frame. I've shown you an example of RDD. Is that clear?
Yes, sir.
Any
Yes.
questions so far? Okay. So let's have another break. Let's have a quick break for like maybe another 10 minutes, then we'll come back. Yes, you remember I said I will go back to the split function, split aspect, yes, the other time. So, while we're on break, I was figure out, the fixing and the splitting. So instead of writing, for loop, so we have a split function here in PySpark already, so which makes it more easier for us to transform. So I just use the same with column, passing a new column name, split, passing the column you want to split. In this case, we're splitting this. Then what are we splitting by? We're splitting by space. Remember, there's a space there. Splitting by space. And if we split by space, we want to pick the first one, like you are picking first index. Zero in the zero as the first element. In the zero. So in the zero is county. So if we run this and pass in get item, remember how we're using list, and we are capturing the first index 0. This is doing the same thing, get item 0, then show. And when you run that, you grab the only first part. If I try to grab the second part now, let me say get item -1, which is the last one. Let's see if it's going to work. Can you see it's working? But it's telling us this. No. So we have another space somewhere. So, but if I use get item 1 after 0, let's see what will happen. So it's capturing few ones there. It's capturing, because here there is no space here. Can you see? There is nothing after Interpol. We only have for County Durham, and we have for Newcastle, upon time. Can you see side? So it's capturing the time side after splitting that. Does that make sense? So that's how it works. And with is capturing this now. Can you see upon here? It's capturing after the first split. Capturing this is the 0, this is 1. 0 and 1 after split by space. This one does not have any space, any split is going to give it as null. If I use -1, let me try minus. Okay, let's leave it that way. So get item. No, it's not going to work because we pass in what? 0 as the first one. What we want to grab. So that's how the split aspect works. Do we have any questions so far? We've come to the end of the class. We've come to the end of the whole class.